In this video I'm going to turn this big ugly chunk of rusty scrap steel into a very heavy and very strong welding table. I got the slab from a friend, thanks Emma, and she did me a very good deal. I only paid the same as the local metal recycler charges for scrap steel. One of the issues I faced was how big and heavy it was. It was slightly less than half a standard sheet, and it's 25mm thick, so it weighs more than a quarter of a metric ton. Luckily when we loaded it we had access to an engine crane, and I have access to an engine crane here too, but there was a mishap with unloading, and one of the clamps I was using to hang the plate from let go, and my crane has a big dent and also a broken wheel mount to prove it. Still, I'm happier to lose a crane wheel than a toe. The next issue was how to cut the thing. I don't have any tools that can cut a sheet this thick, so I splashed out and bought myself a 175mm grinder. That did the job quickly and easily, and to keep the cut straight, I clamped a straight batten to the workpiece. This straight edge worked exceptionally well, and I'm surprised just how straight the edge ended up. I'm saving up for some martial arts lessons though anyway, because the karate chop that the other YouTubers use looks like a real time saver. Whenever I use an angle grinder in the shop, I use this fiberglass screen that I made to control the abrasive dust. It's made from a fire blanket stretched over a lightweight timber frame. It's not perfect, but it does help a lot. When I see the pile of abrasive and metal dust that gathers at the bottom of the screen, I'm always glad I put it in place. There are lots of ways to get rid of rust, and I go through a few of them on this project. But my first instinct, since this plate was so bad, was to use the wire wheel on the angle grinder. This worked okay from a rust removal point of view, but it made a terrible mess throughout the workshop. It was not a fun couple of days cleaning that mess up. Vinegar was my next experiment, and I bought the strongest I could find, which was a cleaning vinegar, and I let it sit on the plate. I used a tarp to stop it drying out too quickly, and this worked well. The problem is that vinegar also corrodes clean steel, so rather than taking a heavily rusted piece and making it rust-free, it leaves it somewhat rusty. But it does take a minimal amount of wire wheeling to take off this final layer. So now I have one clean surface and I'm ready to start work on the frame. The legs are a 100mm square steel tube, 4mm thick. The stretchers are smaller and will sit low on the frame to function as a shelf support and also as a pallet jack lifting point. I figured why not use the welding table top to build the frame. It's so much more convenient than trying to shim wooden sawhorses like I was doing before. Also, the fire risk has got to be lower. That reminds me, I must phone the insurance company and ask for a lower premium now that I have a non-wooden welding table. The frame went together without any big problems, and I did the usual technique of tacking the corners that were longest to give me some wiggle room to square things up properly. My strategy was to build two flat horseshoe shapes independently and then join them with the final two stretchers at the end. I got the flatness of the horseshoes pretty much spot on, and the squareness at the end was not perfect but not bad. With such a lot of straight fillet welds, I took the time to practice my stack of dimes technique, and the best tip I can give is that using a thicker filler rod really helps to freeze the puddle between moves. That was enough to take mine from passable to quite attractive, at least to my eyes. Now I need to cap the legs, and to do that I used an offcut of the same tube, but I cut it to a size that fits inside the tube and then split it on the bandsaw and derusted it on the wire wheel. The reason I went for inset end caps is twofold. One, it makes calculating the leg length a bit simpler, and two, I didn't want to see any welds around the perimeter of the feet at the end. With the end caps all in place and the welds dressed, it's time to flip this thing right side up. I used a pair of winches to make this happen, and here's the first time you're seeing the untouched top of the table. And it's a bit disheartening seeing that much rust again, but at least it's not ankle level anymore, so working on it will be a lot easier. Some of the edges do need quite a bit of work, but still, it's something I'd do with a grinding disc and spot work the area, not make a fresh cut with a slitting disc. My next rust removal method was electrolysis. You often see people removing rust in a tank of electrolyte, but I'd never seen a video showing how to remove rust from a big sheet, so I thought I'd share this technique. I used a DC power supply to provide the power, and I used a bunch of rags to hold the electrolyte. There was some electrolyte dripping down around the table, but I put plastic sheets down and this stopped the concrete from staining. The negative side of the power supply was connected to the table, and this is the cathode, and the positive side of the power supply was connected to some sacrificial sheets of steel on top of the rags. This forms an anode. Electrolysis will gradually eat the anode and turn it into rust while cleaning the cathode, so you have to make sure the anode is something you don't care about, and you have to make sure it's fairly rust-free, because I think the more clean metal the process has access to, the lower the resistance in the circuit and the better and faster the electrolysis will work. With such a large surface area, I found I was only able to run a very low voltage without bumping into the current limit of my power supply. So I started using a smaller anode, which worked better. It focused the derusting onto a certain area of the tabletop, and this worked well, but it was still slow. And now I had to do overlapping sections of the table, and it took a few days to get these results, because I was unwilling to run the process overnight. I only really wanted to run the power supply flat out when I was nearby. Deciding this was too slow, I did a bit of research online and worked out a new rust removal method using acid. The vinegar was also a bit too slow and left a thin film of rust anyway. Citric acid is better, and I've used it before, but I didn't have any in stock. And I'd heard good things about hydrochloric acid, also sold as pool pH reducer. And it does work great, but it's a volatile acid and it releases an acid vapour which will rust everything in the room. I stumbled upon oxalic acid, which I've used in the past as a wood bleach for removing stains and so on. It turns out it's quite a potent rust remover, but it doesn't hurt the other metal objects in the same room. So I made up an oxalic acid solution and I slathered it on the table, and I saw pretty good results from that. The only downside is you must neutralise the solution before you get rid of it. Adding sodium carbonate, which is washing soda, a little bit at a time until it stops fizzing is one way, or bicarb is another way. I used rags to mop up the resulting stable salt, which should be pH neutral, and those rags can then be dried out and chucked away as normal. I spent a bit of time on the flame cut edge of the table and it was looking quite gnarly. So I took off the high spots until the low spots looked manageable. Then I got in there with a small carbide burr and dug out any rust pits. Those were then filled with weld material and dressed back to give me a clean edge. One of the requirements of this table is to hold all my G-clamps. You might have seen my clamp rack in an older update video, but having the G-clamps several paces away from the welding table where they'd be used all the time made no sense to me, so I decided to put clamp storage on the table itself. It's just a rod welded in place. Now the basic table is together and rust-free, next on the agenda is some steel drawers. I've got a bunch of metals and plastics in carts, boxes and trays, and I've got bigger pieces on the floor, and it's all littered around the workshop and they take up valuable floor space. One of my requirements for this table is that it holds all my offcuts of machining stock, and that means shallow, heavy-duty drawers in the top half and a shelf in the bottom half. I decided to fabricate the drawers from flat bar steel and to lay in a loose timber base to reduce costs. Fabricating from flat bar steel turned out to be a big pain, with welds contracting and making the drawers non-straight and non-square. So although it's come out acceptably well in the end, I did a lot of heat shrinking and fettling and cutting and rewelding of welds that I'll not use this method again, and I don't recommend it. On the plus side, I did obtain some 4mm aluminium panels from Gumtree for about scrap price, and these made a great set of liners for the drawers, so I didn't have to make timber ones. I did have to buy a couple of aluminium specific cutting discs for the angle grinder, and the recip saw got a workout too. But I got all the panels cut for a loose floating fit, and the drawers are now running on their slides. I decided to inset the front of the drawers enough that I could make a wooden front and a drawer pull. The wood I started with was Taz oak, but it was pretty rough, and I always enjoy the process of planing and sawing away the scruffy bits and revealing perfect timber underneath. I've used this drawer pull design in the past and it's strong and comfortable to use. I can either use one hand at each end to open the drawer or a single hand in the middle if I have the other hand full of material, so it's quite versatile. Also, one big drawer pull gives you fewer edges to catch your clothes on. The next item needed was a big low shelf, and I had a sheet of reclaimed form ply in stock, which I also got second hand from Gumtree a year or two ago. I trimmed it carefully to exclude as many holes as possible, but I'm left with one hole in the middle, so I might have to make a label that says drain here. Once the drawers and shelf are done, all that's left is to load it with materials. So I've saved my top shelf materials for the top shelf, or drawer. Brass, bronze and known alloys of steel, like 4140 and 12L14 and tool steels. The next one down has stainless and mystery steel, but all looks like good machining stock. The third drawer is all aluminium. And the fourth drawer is heavier, rough stuff that's mystery metal that I can't bear to part with. And the bottom shelf is for chunky bits, which are too big for the drawers. Now I know it's not painted yet, but it's still winter here, and painting is best done in the warmer weather. In any case, I have a couple of mods in mind already for this table, and they should really happen before I paint it, but you'll have to stay tuned to find out what they are. Thanks for watching.